Welcome students. Today we will draw isometric view of cone frustum, and we have considered the base diameter of the cone frustum as 50 mm, height of the frustum is 50 mm, and its top diameter is of 30 mm. So let us see what steps we have to adopt in order to draw the isometric view of this cone frustum. Whenever we have to solve such problems, we have to make one assumption first, that our solid is enclosed inside the box, and we will draw isometric of that box first. Then in that isometric we will generate isometric of the solid. This process is known as box method. Now you can see over here in this answer, we have first drawn isometric of the box, in which we have assumed that our solid is enclosed. Then inside that isometric, we have drawn isometric of the solid, which is a cone frustum. Now let us see what dimensions we have to take for that isometric of the box. And dimensions of the isometric of the box will depend upon the larger diameter of the cone frustum and height of the cone frustum. Now you can see over here, the larger base diameter of the cone frustum is 50 mm. It means length and width of the box will be 50 mm. And height of the cone frustum is 50. So height of the box will also be 50. It means first step is we should draw isometric of this box of length 50, width 50 and height 50. It means it is a cube. So first of all we have to draw isometric of a cube of size 50 mm. So for that what we will do? We will draw a small horizontal line of around 20 millimeters and consider this point, and on that point place the protector and mark 30-degree angles on both sides. After that, we will connect these 2 points with the help of scale, and we will draw the first isometric axis and we will draw it continuous thin. Then we will connect these 2 points to get the second isometric axis, and we will draw this also continuous thin. So we will draw any length at the start. Now after this, what we will do? We will cut these 2 lengths to 50 mm, which is the diameter of the cone frustum. So let us open compass to 50 mm. And let us cut these 2 axes to 50. So place your compass at this point. Cut this axis to 50 with a continuous thin arc, and cut other axis also to 50 with a continuous thin arc. Now from these 2 points, we will draw 2 more arcs of same distance, that is 50 mm, because we are constructing isometric of a cube, and over here the base of the cube is a square. So isometric of a square will be a rhombus. So first of all we are drawing isometric of rhombus. So from this point we will mark arc at 50 mm. Then we will place compass at this point and we will draw the second arc which will intersect the first arc, and draw these arcs thin. Now after that we will connect these 2 points with a continuous thin line. Draw it carefully. Then we will connect these 2 points with another continuous thin line. You can see we have drawn isometric of the base of the box, which is isometric of a square. So this is a rhombus. Now what we will do? We will erase the extra lines over here. Now in order to draw the isometric of the cube, we have to raise these four corners equal to height, which is 50. So let us place scale at this corner in vertical position. Align your scale in vertical position carefully and draw a continuous thin line of 50 mm. Then place your scale at this point and align your scale carefully in vertical direction and draw a continuous thin line of 50. Similarly, from this point, draw a continuous thin line of 50 mm by placing scale in vertical position, and when you will draw a line of 50 mm from this point, it will exactly stop at this corner. So this is the geometry of isometric projection of the cube. So don't get confused. When you will draw a vertical line from this corner, it will exactly stop at this corner. Then from this point, we will draw another vertical line of 50 mm and align your scale carefully in vertical position to draw that line. Then we will connect these 4 points with the help of continuous thin lines. And when you will connect these 2 points, you will find that this is a single line. So this is the geometry of isometric view of the cube. Then align these 2 points with the help of scale and draw another continuous thin line over here. So when you will draw this line, you will find that these 2 lines will be in line. Then after that, we will connect these 2 points with another continuous thin line. Then we will connect these 2 points. So in this manner, we will draw isometric of the cube. So this is isometric of the cube. But we will keep everything thin at the start because this is not the final answer. Final answer is the cone frustum, which we have to draw in this box, which is a cube over here. Now we know in order to draw this cone frustum, we have to first draw its base, which is an ellipse. And this base is of 50 mm. And in order to draw this ellipse of 50 mm, we need sides of 50. And we know the base of this cube is also of 50 mm. So it means we will use this base of the cube to draw ellipse through 4 center method. So let us apply 4 center method in this face. And for that we know we have to use the corners of the shorter diagonal. So this is the shorter diagonal. So this is center number 1 and this is center number 2. And after this we will mark the midpoints of these 4 sides in order to apply the 4 center method. Now we know the length is 50, so we will open compass to 25 millimeters. So let us open compass to 25 millimeters. Then put your compass at this point and cut this length to 25. Similarly, cut this axis to 25. Then put compass at this point and cut this axis to 25 with a continuous thin arc. Similarly, from this point, cut this line to 25. So we have marked midpoints of all the sides. Then from center number 1, draw thin lines to the midpoint of opposite side. So for this point, these two are the opposite sides. So from this center, we have drawn thin line to the midpoints of opposite sides. Same step we will do from center number 2. So for center number 2, these two are the opposite sides. So from center 2, draw thin lines to the midpoint of opposite sides. Similarly here. In this manner, we will generate 2 more centers. So this is center number 3 and this is center number 4. So we'll make use of these 4 centers to draw 4 arcs to draw this ellipse. So for that, use your compass, place compass at this point, open compass to this distance and draw arc between these two curves and keep it thin, because this will be hidden behind the curved surface. We'll put compass at this center now and radius equal to this length. We'll draw arc in between these 2 points and it will be thick because front edge is visible to us in the isometric view. So let us draw a thick curve here. Now after that, we will place our compass at the third center and we will connect these 2 curves with another curve. And radius will be equal to this distance or equal to this distance because these 2 distances are same. After that, we will place compass at this center and equal to this radius. We will open the compass and we will draw the 4th arc. Now we have drawn the bottom face of the cone frustum, which is an ellipse. Now we will draw the top face of the cone frustum. Now for that, we have to understand a very important point, that the top face diameter of the cone frustum is 30. But over here the size of the box is 50. So in order to generate that ellipse of 30, we need a box of 30. It means inside this box of 50, we have to first draw a box of 30. Inside that box, we will draw 4 center method to generate ellipse of 30. So next step is we should create or we should draw a box of 30 millimeters inside this box of 50 millimeters. So for that, what we need to do? We need to mark the midpoints of these 4 sides first in order to draw 2 center lines. Now we know this side is of 50, so let us open compass to 25 again. Place your compass at this point and cut this length to 25. Similarly on other side, 25. Place your compass at this point, cut this length to 25. Place your compass at this point and cut this last length to 25. So we have marked the midpoints of all the 4 sides. Now these midpoints will help us to draw 2 center lines. So align your scale with these 2 points first and draw a continuous thin line, which is the first center line. Now align your scale with these 2 points to get the second center line. You can see the intersection of these 2 will be obtained on this vertical line only. So this shows us that these are correct. Now in the next step, we will draw this box of 30 by 30. So for that, we will make use of these 2 center lines. And what we will do, we will open compass equal to half of this total distance. This total is 30. So we'll open compass to 15 millimeters. And we'll place compass at this center. And we will draw 2 arcs on this center line. One on this side of the center, second on other side of the center. So from center, we have marked an arc on this line, center line, 15 this side and 15 on other side. Similarly, we will mark 2 arcs on this center line. So from center, cut this center line to 15 on this side and 15 on other side. Now we'll make use of these 4 points to draw this box of 30 by 30. So for that we have two methods. One method is that you should have a roller scale. Align your roller scale with this edge, roll to this point marked by you, and draw a thin line over here which will be parallel to the outer line. Similarly, we will align our scale with this edge and we will roll carefully to this point, and we will draw another line over here which will be parallel to the outer line. Similarly, we will place our scale, roller scale, aligned to this edge, and we will carefully roll to this point. We will draw another line which will be parallel to the outer edge. Similarly, we will align our roller scale at this edge and we will roll back carefully to this point marked by us. We will draw another line which will be parallel to outer edge. So by doing this step, we will generate a box of 30 by 30 over here. If you don't have roller scale, then you can use compass for drawing that box. So with compass, what we can do, we will use these 2 points first to create a corner over here. So we'll open compass to this distance which is 15 mm, and we'll mark this distance from the opposite point. So we have measured the distance of this point from the center which is 15, and we'll mark this distance from the opposite point. Then we will measure the distance of this point from the center and we'll mark that distance from the opposite point. But in this case, both distances are same, both are 15, 15. So measure this distance which is again 15, but mark from opposite point. So we will generate an intersection which will be the corner of this box, this corner. After that, we will make use of these 2 points. First of all, measure the distance of this point from the center with the help of compass which is 15 again, and mark from the opposite point. Continuous thin arc. Then measure the distance of this arc from the center with the help of compass which is again 15, and mark from opposite point which will intersect the first arc. We will get another intersection which will be the corner of this box, this corner. After that, we will make use of these 2 arcs. Measure the distance of this arc from the center which is again 15, and mark from the opposite arc. Then measure the distance of this arc from the center, that is again 15, and mark from opposite arc which will intersect the first arc. That will be third corner of the box, means this corner. Now we will use these 2 points. First measure the distance of this arc from the center, that is 15, and mark from opposite point. Then we will measure the distance of this point from the center, that is again 15, mark from the opposite point. So in this manner, we will generate the 4th corner of the box. So if you don't have roller scale, you can use this method to create 4 corners of this box of 30 by 30. And after that, we will align our scale with these corners carefully, and we will draw continuous thin lines. Then after drawing these lines, or after completing a box of 30 by 30, we must cross check that are these lines drawn by us parallel to the outer boundary. Now you can see this is parallel to the outer boundary. This edge is parallel to the outer boundary. This is parallel to the outer boundary. This is parallel to the outer boundary. So this ensures us that our isometric of 30 by 30 is correct. Now in this box of 30 by 30, we will apply a 4 center method to get this ellipse of 30. So we have 4 corners and we will target those corners which are of shorter diagonal. So this is center number 1, this is center number 2. And we have to mark the midpoints of all the sides, and we have already marked the midpoints. So from first center, draw a thin line to the midpoints of opposite sides. So for this center, these two are the opposite sides. These two are the midpoints. So from this center, draw a thin line to the midpoint of opposite side. So from the same center, draw a thin line to the midpoint of opposite side. Same step we will do from this center. So for this center, these two are opposite sides. So these two are the midpoints. So from that center, draw thin lines to the midpoint of opposite sides. So in this manner, we will generate 2 more centers, which will help us to draw 4 arcs or to form the ellipse. So let us use this center first. So place your compass at this center and open compass to this radius and draw a thick arc between these 2 points. Then we will put compass at this corner and open compass to this radius and draw arc between these 2 points, and it will be thick. Now after that, we will use this center and this as radius to draw the third arc, which will connect the first 2 arcs, and this must be thick. After that, we will put compass at this center and this equal to radius of the compass. We will draw 4th arc, which will connect the first 2 arcs. It must be thick. Then after that, we will place our scale tangent to both the arcs, and we'll draw a thick line over here, which will be the slant edge of the cone frustum. Then place your scale over here tangent to both the arcs and draw the second slant edge of the cone frustum. And now you can see we are ready with the isometric view of the cone frustum. Now we have to place the dimensions. So align your scale with this isometric axis. Leave 1 meter gap, continuous thin line. Then align your scale with this isometric axis. Leave 1 millimeter gap and draw a continuous thin line. So these two are isometric extension lines. Then use your roller scale. Align your roller scale with this edge, that is isometric axis. Roll back by around 15 millimeters and draw a dimension line, which will be isometric dimension line parallel to this isometric axis. Add closed fill derivatives on both sides in 3:1, and over here we will write 550 in Gothic style, and we will erase the extra extension lines. So extension lines should be 3 to 4 mm after the arrowheads. Then we will place the height. So align your scale with this isometric axis. Leave 1 meter gap, draw a continuous thin line. Align with this isometric line, leave 1 meter gap, draw a continuous thin line. Then in between these two isometric extension lines, draw a vertical line, which will be isometric dimension line. Then add closed full arrowheads on both sides of this dimension line in 3:1. And over here we will write its height, which is 50 in Gothic style. Then we will place its top diameter. So for that, align your scale with this isometric line. Leave 1 meter gap, draw a continuous thin line. Then align your scale with this isometric line, leave 1 meter gap, draw a continuous thin line, which is extension line. Align your roller scale with this isometric line, roll back by 10 millimeters and draw a thin line in between these two extension lines. So this must be parallel to this isometric line. And add closed fill arrowheads on both sides of the dimension line. And we'll write this diameter as phi 30 in Gothic style. So we have placed its base diameter, top diameter and height. Now we'll place the angles. So extend this horizontal line on both sides. Draw a thin curved dimension line, add closed fill arrowheads on both sides. And in Gothic style, in aligned system, we will write 30 degrees. Similarly, on this side, we will add a curved dimension line, add closed fill arrowheads on both sides. And in Gothic style, in aligned system, we will write 30 degrees. So now we are ready with our answer, that is isometric view of cone frustum. Thank you very much.